Hey everybody, and welcome to another installment of the College Algebra Enhancement video series. In this video we're going to be talking about multiplying and dividing rational expressions. This is video 1 of a 2-video series. So before we begin, let's of course actually define what a rational expression is. Okay? So a rational expression is the ratio of two polynomials. So we have in previous videos learned what a polynomial is. And the only condition is that the denominator of this expression, of this ratio, cannot be the zero polynomial. Okay? So let's get a couple examples here. X squared plus 2 over x cubed minus 6x plus 8. This is a polynomial in the numerator. This is a polynomial in the denominator. This is not the zero polynomial, so we have ourselves a rational expression. The same can be said about x minus 5 over x plus 4 and 4 over x squared minus 4. This one is a little tricky. 4 actually is a polynomial. It's a polynomial of degree 0, but it is in fact a polynomial because you can write 4 as 4x to the 0. X to the 0 is just 1. Okay? So let's review how to multiply and divide fractions. So before we actually learn how to multiply and divide rational expressions, let's just review how to do this with fractions. So if you have a fraction a over b times c over d, in order to multiply these, we multiply straight across in the numerator and straight across in the denominator. So you end up with ac over bd. And for dividing fractions, if you have a over b divided by c over d, this is the same as having a over b times d over c. Okay? D over c is called the reciprocal of c over d, and we get that just by flipping this fraction over. Alright, so that's the reciprocal. Dividing by a fraction is the same as multiplying by the reciprocal. And then we know the rule for multiplying fractions, so this is, you multiply straight across, AD over BC. Alright, focusing on multiplying, so let's first look at multiplying fractions. So 1/2 times 3/8, you multiply straight across. 1 times 3 is 3, and 2 times 8 is 16. We're then going to want to leave this in lowest terms, so 3/16 is as reduced as it can be. In this second example, I have 16/5 times 25/8, and before you actually execute the multiplication, a nice trick is to look at where we have common factors. So I notice that 6 and 8 have a common factor, and I notice that 5 and 25 have a common factor. So I can rewrite 6 as 2 times 8, and then I can rewrite 25 as 5 times 5, and then in the denominator you just have 5 times 8. Alright, so I'm rewriting 16 as 2 times 8, and I'm rewriting 25 as 5 times 5. So before we multiplied anything out, I can now look at this and say, alright, I have a factor of 8 on top and a factor of 8 on the bottom. Those are going to cancel. And I have a factor of 5 on top and a factor of 5 on the bottom. Those are going to cancel as well. And all that you'll have left excuse me, is 2 times 5, which is 10. That's a lot simpler than trying to multiply something by 25 before you begin. Over to rational expressions. So here's our main example of the video. Let's find each product and reduce to lowest terms. And I'll explain what that means when we get through these examples here. So just as before, before you actually multiply, I want to fully factor all of the pieces of my rational expressions here. So on top I have x minus 2 of the first one. On the bottom I have x plus 3. Those are as simple as they can be. But this bottom piece, x squared minus 4, can actually be factored. It's the difference of squares. If you remember our special product video, it's x minus 2 times x plus 2. Okay. Now you can look at the entire expression, and I notice that I have an x minus 2 on the top and an x minus 2 on the bottom as a factor. So those are going to cancel before I even proceed. And the next step would be to write what you have left on top, that's an x, and then write what you have left on the bottom, so I have x plus 3 and x plus 2. And that's it. That's the lowest terms. Those are the lowest terms for the product that we found from these two rational expressions. Let's look at part B. So again, let's factor before we begin. So I have x minus 3 on the top here. That doesn't change. X plus 1 does not change. But these other two pieces we can factor. So I have x squared plus 2x plus 1. If you factor this as described in a previous lesson, you're going to find that this is x plus 1 squared. And then if you move on to this denominator, x squared minus x minus 6, you're going to find that this is x minus 3 times x plus 2. Okay. We then can look at this expression as a whole, and I see that I have a factor of x minus 3 on the top here, which will cancel with the x minus 3 over here. And I also have a factor of x plus 1 on top, which will cancel with one of the x plus 1's on the bottom on the left here. So the way we indicate that is we cross out the 2 and rewrite what the exponent would be. So the exponent now would just be a 1. So one of those factors cancels with the factor in the numerator. And so what we're left with is a 1 on top. There's no x's left on top. And then an x plus 1 and an x plus 2 in our denominator. These are the lowest terms for the product we got from multiplying these two rational expressions. Let's finish with one last example here. So the first step is to factor every piece of each expression. So on the top left, I can take out a greatest common factor of a 3. On the bottom, I have a 12. 4x stays. And then x squared minus y squared, notice that's a difference of squares again. So we have to use all of what we learned from factoring to factor these guys completely. And then I can look for common factors on the top and the bottom. So I have x minus y cancels with the x minus y. And then we proceed with the multiplication. So we multiply straight across and straight across. So on top you're going to be left with 12x. And on the bottom you'll be left with 12 times x plus y. And we notice that those 12's are going to cancel. And our final answer in lowest terms will be x over x plus y. Okay? I'll see you guys in the next video where we're going to be talking about how to divide rational expressions. And have a good one.